All right, so let's go ahead and do that. I'm going to find, I want a black pen. I don't know why I want a black pen, but I want a black pen. I want to find the equation of the tangent line to, wow, got a little ahead of myself on that, didn't I? A little too much caffeine for lunch. The equation to y equals root x at, let's go, I don't know, x equals 9. Now, again, let's think visually before we get crazy with algebra and all that crazy business. All right, if this is y equals root x, the first thing that I'm going to think about is, okay, if x is 9, then where does that put me on the function? You know, just so I have that in my brain. Well, it's the square root of 9, which is 3, last I checked. And I like that because it gives me a point. Okay? It just gave me x to begin with, but now I have a point. So I'm halfway home. All I have to do is figure out the tangent. The slope of the tangent line. Got a little distracted there for a second. So here we go. I'm going to use this guy first, and I'm going to just prove I really like this form of the slope of the line tangent to begin with. I'm going to use this guy, okay? X minus a. Now, the question is what is a? The question is what is, that's too many is's, but sorry. This is a. A is always the x value at which you're trying to find the slope of the tangent line, okay? So here we go. The slope of the tangent is equal to the limit as x approaches 9. Now, the way in which I draw my a's, it almost looks like a 9, doesn't it? And I've got f of x, which is root x, minus f of a. So f of 9 was 3, right? All over x minus 9. Okay? Fair enough? Now, so what do? We plug it in, plug it in. I throw a 9 in here, I get 3. 3 minus 3, 9 minus 9, 0 over 0. Boo. Unhappy. Okay, so there's lots of ways that we can do this. If you remember correctly, if I want to, I can multiply. Let's change color pen so we see that we're doing some crazy business here. I'm going to rationalize the numerator, just so you guys can see it again, so you don't freak out if you see it down the road. I'm going to multiply. Let's get rid of this. Actually, let's erase that, just so it's out of our way. I'm going to multiply top and bottom by square root of x plus 3 over the square root of x plus 3, affectionately known as a goofy looking 1. Now, why am I doing that? I don't know, because it might help me out. Let's see what happens. If I multiply this times this, that's a difference of 2 perfect squares, so I'll get the limit as x approaches 9 of x minus 9. Ooh, I'm already getting happier. You see why? Because I'm going to cross out that x minus 9 in the denominator, which was giving me fits. It produced the 0 in the denominator. 0's in the denominator, bad. So I got root x plus 3. Cancel. Thank you for playing. And I end up with the limit as x approaches 9 of 1 over root x plus 3. Plug it in. Plug it in. Square root of 9 is 3. 3 plus 3 is 6. Guess what? Check this out. I'm like done. I've got a point right here. I've got a slope right here. It looks like y minus 3 equals 1/6 times x minus 9. If I ask you to put this into slope-intercept form, or if I ask you to graph it, then you need to solve for y. But if I don't, I'm done. Ding, ding, ding. Nothing to it. Now, let's actually go through the process with the limit as h goes to 0 of f of a plus h minus f of a all over h. Now, remember, students often freak out and they're like, wait, what's going on with this h thingy? Well, what was h? H was the value when we went on our fishing expedition. Remember this? If I go back here, h was this value that we're sucking back to x. So it's really, the only reason it's there is so that we can take the limit as it goes to 0, because we had that, remember, we had that difference quotient. We had that algebraic construct that built our slope of the secant line. All right, but right now, we're just going to leave it as an h until we can make it disappear or take the limit as h goes to 0. So, ready? Here we go. The limit as h goes to 0. Notice that h always goes to 0. By the way, we are looking for the slope of the tangent line. So in this equation, h always goes to 0. In this equation, x always goes to a. And that can be the source of some frustration and confusion for students as well. So you got to figure out a way to keep those separate. All right, so this is going to look like, I'm going to write this out longhand. A in this case is 9. Remember, that's the value that we're going to. So 9 plus h, right, minus f of 9 all over h. You don't have to do this when you're doing homework for me. I just want to make sure that I do it, okay? So let's see, this is the limit as h goes to 0 of the square root of 9 plus h minus, well, f of 9 was 3, right? So minus 3 all over h. If I stick 0 in, you get the square root of 9, which is 3. 3 minus 3 is 0 over that crud, right? So this is going to turn into 0 zeros. Okay, so now in this case, we're kind of stuck. We have to rationalize. So I'm going to pull exactly the same trick, only, let me change colors to do it. Well, I'm going to do root 9 plus h plus 3 over root 9 plus h plus 3. It's just a goofy looking 1. I can multiply by 1 anytime that I want. And let's see what happens. Hopefully we can make those h's disappear, or at least that h, right? That's the bad guy. So I end up with the limit as h goes to 0. It's a difference of 2 perfect squares. So I'm going to get 9 plus h minus 9, right? All over h times root 9 plus h plus 3. Hey, look at that. 9's go away. All right, which also means, look at how pretty this gets. I get the limit as h goes to 0 of h over h times root 9 plus h plus 3. Now, students will often say, Ripley, how do I know when I'm done doing algebra? Well, think about it. We know that there is an equation of a line tangent. We know that that exists on this function at this point. So I know that this limit has to exist. I know that this limit right here has to exist, which means I need to continue to do work until that h and that h cancel. As soon as those cancel, then I'm in business. I know that I'm no longer going to have this 0 in the denominator. It's going to go away. All right? Or it's going to be there and I can't get rid of it, and I just realized that the slope of the tangent line is infinity, so it's going to be a vertical tangent line. All right? So if I do 9 plus h plus 3, if I plug in 0, I get the square root of 9, which is 3 plus 3, and same exact thing. Isn't that awesome? That's very, very cool. All right, let's talk specifically about velocity. Well, what do we know that velocity is? This is the instantaneous rate of change of position, right? Well, we know that instantaneous rate of change is actually the slope of the tangent line, right? So if I'm given position, these are typically written as x of t, s of t, you'll hear them y of t, things like that. I mean, you'll see all kinds before everything. So sometimes you see this as d of t, where it's representing like a distance. Then I know that if I want to find the velocity of any one of these, if these functions are representative of a position of a particle, then I know the velocity at any point A can be written as the limit as as t approaches A of any one of these. To keep it simple, I'm going to do s of t. All right? So this is going to be s of t minus s of A over t minus A. I could also write this, if I wanted to, I could write it as the limit as h goes to 0 of s of A plus h minus s of A all over h. Remember, these letters, whether they're f's, s's, y's, d's, who cares? They're chosen arbitrarily. They're chosen just really to differentiate one function from another. So don't be afraid to see an S. Just realize that these guys right here, all of these equations, sorry, I'm changing colors on this thing. All of these right here are position. And the instantaneous rate of change of position is velocity. Isn't that awesome? All right, good times. Now, let's make sure that we understand what that means. If I'm given I'm going to change this up. Yeah, no, let's call this s of t. If I'm given a function, s of t, all right, and I can figure out what the slope of the line tangent to s of t is, so that I'm going to call this point A, comma, s of a. So this is the position of a particle, right? And this is going to be t equals a. If I can figure out the slope of this tangent line, remember, this is really v of a. I can figure out exactly how fast that particle is going at that point in time, which is pretty revolutionary. Pretty cool. All right, well, thanks for listening. I'll see you in class tomorrow. We'll get some math done. All right, have a really good day.